So let's see. Yes, again, I will present the result that I'm not the primary producer of. Instead, it is Therese Berggren, that was a master student that has done most of the actual work here. So this presentation will be about increases in body growth of pike with the warmer water, but that the mortality has a larger impact on decreasing body sizes. So especially the previous presentation showed that the large pike has been declining in the Baltic Sea, and there can be several reasons for this. So one reason can be an increased temperatures. When the temperature increase, usually fish can increase their intake since they are ectothermic, so they have the same temperature or similar temperature as the water. So intake rate can increase up to some point. But also metabolism increase, and metabolism is size dependent. So if you have a rather small body size, your metabolism is quite high at low temperature, but it doesn't rise as fast as temperature rises. Whereas if you're a large-bodied fish, you may have a low metabolism at low temperature, but temperature may rise quite quickly with temperature. That means that the optimal temperature for body growth, given that there are sufficient of food, of course, may differ depending on the body size, so that a larger pike or fish in general would grow, has their optimal growth. Did I say right here? A smaller, a larger pike. Sorry, now my brain is out of work here. But a larger pike would have a lower optimal temperature than a smaller pike here. So that can be one thing. And then, as Ulf just recently said, and other presenters has also indicated that there can be an increase in mortality of pike that can shift the body size distribution to smaller. I mean, basically, you start with the same number of individuals, but if the mortality rate is higher, you're left with fewer large-bodied pike. There's basically a lower probability of becoming large. So these are two different ways that may affect the body size growth and body growth of pike that we wanted to investigate. So at the Swedish Agriculture University, we have actually stored the data or stored the samples from pike from both the Baltic Sea and from Lake Mälaren, which is one of the major lakes in Sweden, close to Stockholm area here. And we have samples from the 60s until last a couple of years ago. And we wanted to study changes in the size distribution in these samples we had. And the samples we had were wing bones, and that is part from the jaw of the pike, and they kind of create like H rings as on a tree, and you can estimate how old a pike is, and also by measuring the distance between these annual rings, you can have an estimated back-calculated length at age. So we use this data on around 10,000 pikes that have been sampled and stored in our archives. to measure body growth and mortality. We basically set up two questions. Is the body growth dependent on temperature, and is it size specific? And also, can we see evidence of size selective mortality? And in that case, there's a higher mortality of larger or fast growing pikes. And I should say that these are they were sampled with static gears like pound nets and pike nets during spawning. So it's a spawning migration fisheries or spawning fisheries, and they used a bit different gears, and there is some differences in relation to gears, but it doesn't. The gears doesn't change the story in no way. I should also point out here that one of the sample site or one of the sampling sites was a no-take zone in Östman County called Novemeber, or actually it was a no-take zone somewhere in the early 1980s. So in the first part of the study period, it was open to fisheries, whereas the other two coastal sites here, Östman and Marsa, has been open to fishery the whole time. I should also warn you or inform you that the sampling has been very unbalanced over the study period. So we have very many samples from the 1980s and 1990s and half the first year of the 2000, and we have rather fewer samples from the 1960s and from the last decade, 2010. As you will see, that will of course affect the certainty of the results, but maybe doesn't change the story so much. First, I just want to show you that water temperature has actually increased in these areas. So here we have in situ measurements in Kvädefjärden, which is close to Liknavaartfjärden, where temperature has increased almost on average on 2 degrees over the study period. This is only the summer surface water temperature. So it's only surface temperature. We don't know what happens deeper, and it's only during the growing season of the pike. Also in Lake Mälaren, there has been an increase of maybe 1.5 degrees. It should be said that this is a quite sheltered bay, and I think this has been taken in the more open areas of Lake Mälaren, not in the sheltered base of Mälaren. So you shouldn't really compare temperature here, but it's only the trend that is interesting. But it has been a clear increase also in surface water temperature in Lake Mälaren. So in both areas, or all areas here, have faced an increase in water temperature over the study period. Yeah, so period A is basically the period before recreational fisheries was allowed in these areas from the 60s and 70s. This graph here shows the size distribution as percentiles. So the upper here is the 19th percentile, like the length of the 90th longest fish, pike. And it's the plus signs here are the medium length, and the crosses here are the 10th percentile, the length of the 10th percent largest fish. And as you can see here, there was basically no sampling in Lake Mälaren between 1970s and 2015. So we lack samples there, and also here in Liknavaart, we lack samples from the late period here. But we can see from the coast that there was a high, actually I would consider this as a sharp or high increase in body length from the 1960s, 70s until the 1980s. The length of the 90th longest fish here increased with almost 20 centimeters. And we can see that there has been a shift in the whole size distribution of pike here in the coastal areas. And it was even larger here in the no-take zone. So these samples are here from period A. It was not a no-take zone, but it became a no-take zone here during period B and C. So it has been to be pointed out. What we can see here that happens lately is that the size distribution has basically become compressed a bit. The largest pike are declining, as we have Ulf presented. But we can also see that the smallest pikes are actually hasn't changed much, or is maybe even increasing in size a bit here in the male, for example. Lake Mälaren clearly stands out relative to the Baltic Sea sites, as there is relatively stable. We don't know what happens here, but there hasn't been a huge change here between 1960s and 2015. That's a small increase maybe. So what does the body growth look like then? Yes, so in the coastal exploited area and in this no-take zone, we can see here that there is an increase in body growth, in yearly body growth with increasing temperature. This is size corrected growth, but so they are assumed to be of the same size here, and the annual growth have increased on average from around 15 centimeter to 20 centimeter per year. So that is of course huge if you're large pike, but it has been assumed that this growth is for a very standardized and very small pike. So of course a large pike doesn't grow 20 centimeters per year, but it has increased with almost 30% over the range and temperature we see here. We see that both it's females to the left and the males to the right here. The header was removed here, unfortunately. But again, we can see here in Lake Mälaren, we don't see any pattern at all with the temperature. So there is something else happening, or nothing is or less is happening there at least. We thought that the body or the relationship between temperature and body growth would be size specific, and it was. It was much or was more evident in small pike. So it's female here and male pike to the right. This explained around 5 to 6% of the total variation. So it's not very much, but a lot of the variation is probably just the sampling errors related to the back calculated length we have. But as you see here, with large pike, which I think is pike about 75 centimeters, of course we have a smaller sample size here, but then the relationship with temperature disappears, but it's not negative. We had thought that maybe the increasing water temperature would cause them to grow less with higher temperatures, but we cannot see that warm years or warm water would negatively affect body growth of larger pikes. And then so first we took a look at the total mortality, and here is from male to the left, females to the left and males to the right here. there was very high estimated mortality in the first period actually here. Yeah, don't really know why it was so high. It of course relates to that they were small and so on, but if this was commercial fisheries or high household fishing or what it might have been, we don't really know. And then it has declined a bit here along the coast, and the last year here is a bit uncertain, but it's not a clear increase, at least in female. For males, the total estimate mortality is partly estimated to have increased. Now, so I say right here, yes, these gray diamonds here are the no-take zones, and in the beginning here, in the 80s, was considerably lower than in the exploited areas. For females, has become more similar maybe, but for males, the difference has increased a bit. We don't know. There is a problem with sample size here, of course, but in general, no-take zones has lower total estimated mortality. But we can also see that especially for females here, the mortality for female pike is actually in parity with the no-take zone at the coast, suggesting that it's not very high mortality in the Lake Mälaren. And then we looked at the size selectivity, and what we found here is that a value of 0 here means that the size of the survivor of a cohort was the same size or had similar size as the survivor of the cohort had the same size as the cohort as the last year. So, and if it's a negative value, that means that survivor of a cohort to the next year was shorter than the cohort average last year. A positive value means that the survivor were larger than the cohort average the previous year. So negative values here means that there is some kind of size selective mortality on larger individuals, whereas a positive value means size selectivity against smaller individuals. And here we have from the different gears, differed between the gears, but the story is basically the same. On average, this size selectivity is negative in all areas and with all both gears, suggesting there is a size selective mortality on larger individuals. However, and this is often referred to as Rosalie's phenomena, so that the smaller or slow growing individuals stay in the population longer. But there's some interesting thing. We can notice that sample size is not that big, but we see the same general pattern here, that there is a size selective mortality also in the no-take zone. So that this might be partly natural driven. And also we can't really see that there is an increase over time that would evidently suggest that that show that the size selective mortality would prevent large individuals or prevent or hinder from pike from becoming really large. So in summary, size distribution have been compressed, and we have fewer large pike along the Baltic Sea coast, at least not in the Lake Mälaren. Increased water temperature has increased body growth, has a positive effect on body growth on smaller pike, but there is no influence on the larger pike, what we can see so far. Mortality is size selective, but it is at least partially natural. And the total mortality was clearly highest in the early in the period. And there has been very small changes in Lake Mälaren, whereas more evident changes in the Baltic Sea. So the implication of this is that the increasing water temperature is not likely a reason for diminishing large pike, and mortality factors is likely another more likely cause for less large pike. But from this study we cannot tell what the mortality factor is. Okay, I took some more time than I should, but thanks for your attention. And this paper is in press in Canadian Journal of Fisheries and Aquatic Science.